questions, you might be able to get into contact with Mark and Emmanuel after the webinar. So let's go first to a recent report that was published. So the Mission Possible Partnership published a report on making decarbonizing the ammonia sector. And what you see here on the right-hand side is kind of the production pathways for ammonia production depending on the scenarios. So if you look at the business as usual scenario, the ammonia production will just stay as it is, mainly natural gas-based ammonia production, and will not grow substantially. It might become economically viable to produce some green ammonia, or as we call it, renewable ammonia, but nothing changes too much. What you, however, see in the middle graph, or even on the right-hand graph, you see that ammonia is set to decarbonize towards 2050, and the biggest chunk of that is renewable ammonia, but especially in the lowest cost scenario, on the longer term, there's also some room for low carbon fossil-based ammonia, what is called here blue ammonia. Next slide, please. And what you see is that right now the renewable ammonia part will be quite small, and on the long term it will be large. And at the Ammonia Energy Association, we looked at what's now the announced capacity for low carbon ammonia production to meet the demand on the long term. So on the long term, you have all these different new markets popping up. So not only the current markets like fertilizer production or chemicals production, but also for the shipping, so the maritime sector, for stationary power generation, or even ammonia as a hydrogen carrier. So what you see here is a graph of all the announced and existing low carbon ammonia production capacity. And what's quite interesting is that there is about 150 million tons of low carbon ammonia production already announced. Part of that is fossil-based ammonia production with carbon mitigation, currently mainly CCU or EOR, enhanced oil recovery, so it's about 4 million tons of annual production. But by 2030, this fossil-based production will be about 15 million tons, mainly CCS. But more interestingly, if you look at the renewable ammonia production, you see that even more is announced to serve the new markets, or even the existing markets, such as fertilizers, as we will hear a bit later today. And by 2030, it is estimated that around 55 million tons of renewable ammonia will be in production. The question is, of course, how much of that will be realized, but it shows that there is really a substantial move towards renewable ammonia. And beyond 2030, the total announced amount of renewable ammonia is something like 135 million tons of ammonia. So it's about 2/3 of the current ammonia production. So this really shows that it's huge. Right now, renewable ammonia production is only very, very small, with only a few plants operating small amounts of renewable hydrogen production for renewable ammonia production. And today we are actually joined by two companies who have been involved in one of the first renewable ammonia production plants based on solar. So that's Mark van Doorn from Fertiberia and Emmanuel Arrizabalaga Prado from NEL. And I would like to give the word to Mark van Doorn.
Okay, well, thank you very much, Kevin. This presentation already looks quite interesting if you look at all the projects of green ammonia coming. And I think, yeah, we're kind of proud that Fertiberia is one of the first companies that actually produce and plan to produce green ammonia in Puerto Llano. So we are. This is a bit how it looks. This is our site in Puerto Llano in Spain, an hour by train under Madrid. So in a very nice place, and usually it's more sunny than on this picture. If you go to the next slide, please. I think Fertiberia is not the biggest company, but we are a reasonable sized company with 1,500, 1,600 employees working on the fertilizer business. And what's more important in this case, we have more than 40 years of experience in producing ammonia on the site. So it's you see a lot of announcements of green ammonia projects, but it does help if you know what ammonia is about and how to make ammonia and how ammonia is different than many other chemicals. Next slide. We use ammonia, of course, to produce fertilizers, and fertilizers is an important factor if you look at the greenhouse gas emissions. And yeah, we said, well, we want to reduce it definitely, and we're also going to do it. And that was the main reason that the Puertollano site is the first site, because we actually, in a very short term, together with Iberdrola, we have managed to be able to make this, let's say, first full-scale production of green ammonia and green hydrogen available, and which is an important step in learning how to make green products, green ammonia, green fertilizers, work on all the aspects that are concerned with it with regard to certification. If you're the first, you have to develop all the new rules that are in place, and it's an important step to have a fully decarbonized production that we intend to have. Next slide. And this is important also with our new plant in Puertollano as a first step to come to our net zero strategy that we have as Fertiberia. Our plan is to become net zero in 2035, which is quite a heavy pledge, and compared to, let's say, all other fertilizer producers, and it's I think it's manageable based on the projects that we have, on which I'm gonna talk about later. Next slide. The plant in Puertollano, we say, is our kilometer zero plant basically, and it's nothing about the future. It's not a project that is coming. It's not a bird in the air, but it's actually something that is there, that is running, that is producing hydrogen at the right place. It's connected to a solar field that's producing the renewable power, and it's yeah, and it runs a lot of tests at this moment actually to produce the hydrogen and to run it into our ammonia plant, which is a few hundred meters down south of this site. Iberdrola is our partner who's producing this hydrogen and has installed the renewable assets. And this is the moment that we can switch to a film that we have built on site, which is kind of a nice representation of how it actually looks and how it's been built up. So if we can start that. We're here at the Puertollano site of Fertiberia, where is the first green ammonia production based on the green hydrogen produced by Iberdrola on this site. What you see here is everything you need for a 20 megawatt hydrogen production. It starts with the power, where it comes in from the solar field, which is 8 kilometers away, feeds with the cable, then it goes to the rectifiers that are on the other side, and then the power goes inside the electrolyzer building, where there are 16 units of 1.25 PEM electrolyzers. Together they're 20 megawatts. This hydrogen then goes via a compressor, which is over there, and it's fed into the storage area, which is over there, which contains 11 of these cigars that contain the hydrogen. We need quite some storage here because we operate with this hydrogen a ammonia plant that is currently run also on natural gas. So we combine the both, because of we need therefore a constant flow of hydrogen going into the plant. And well, since the power comes from a solar plant, you know for sure it's going to be dark at night. So we need a buffer storage, and this is quite an extensive storage that we have here to cover us through the night. Of course, 20 megawatt is a beginning, and we learn a lot from it to do it here. And for that you need a constant hydrogen use. So you can only do that at a site where you already produce ammonia. And then you have two choices. And we have a good cooperation with Iberdrola on both sites where we produce ammonia. And this is Puertollano, is the one. Palos is the other one in Spain. sustain, and we started here because this gave the best principles. Also the solar field here was the earliest available.
And at the moment we are standing next to the biggest green hydrogen electrolyzer in Europe, isn't it?
The biggest green hydrogen electrolyzer, and it's also the first green ammonia production and green fertilizer production in the world.
You think that's the future?
Yes, it's definitely green ammonia is the future. I think looking into the future, you will have dedicated green ammonia factories. This is a hybrid factory. This is excellent to learn and to see all the tricks that you need to do to handle this hydrogen, handle it on pressure, how to do this, how to make ammonia with it. And it gives us a great learning. So it's a good advice to everybody to start small. And don't think in gigawatts from the beginning, but then you can build this up. And the next step will be the extension of the projects here in Puerto Llano and Palos, but also 100% green ammonia plants. Okay, thank you very much. I think this does it. This is quite self-explanatory. What I have to say is that, of course, we are running this installation. Iberdrola is running this installation. It's still in the test phase as we speak. We have produced green ammonia on the site, significant quantities, but it is we're still learning, and it's not as easy as it looks on paper. Of course, everything works, but especially the combination to do this in a hybrid mode is not the easiest thing. But this has everything to do with the first step, and the first step you do at the first place, and that's therefore the kilometer zero of sustainable fertilization of the future. We are working on using this green ammonia to produce green fertilizers, and that's our target, our main target at this moment, to replace our gray fertilizer production with green fertilizer production, and also working on this green ammonia market, which comes later maybe, and it's going to be big. Let's go to the next slide. There you see a little bit our other projects that we have in place. These are projects that are different because they're different on the different locations, and they are also specifically tuned towards the different locations with its benefits. So it can be either grid connected in places where there is enough additionality, where 99% of the power is already renewable, or it's a combination of solar and grid connection, or it is purely solar, which is not off-grid. So there are different options that we have, and also different timings, but with all these projects together, we already produce roughly 1.5 million tons of green ammonia, and we have more projects in the pipeline that I cannot speak about yet at this moment. So it's quite an interesting combination of projects that we handle at this moment in order to come to our net zero pledge that we have made. And with these projects, we definitely are capable of replacing all the ammonia that we need with the green ammonia and have a surplus in a number of years. Next slide is the last. So this is, thank you very much for looking. I'm available for questions, but I let Kevin manage that, and then looking forward to fill in all the promises that we made and become a net zero company in 2035.
Thank you so much, Mark. That was very enlightening, and also very nice to see how you're actually already doing this renewable ammonia production, and the timeline is actually quite short. We have like 13 years from now to get to net zero from your side, so that's really great. I still want to remember everybody in the chat, all the attendees, that you can post your questions in the chat. So if you have any question for Mark or for Imanol, who will be speaking now, please feel free to ask them in the chat. And without further ado, I would like to introduce our second speaker, Imanol Arrizabalaga Prado, who works at NEL, and he will explain us about the electrolyzer technology that was actually used in this project.
Yes, thank you, Kevin. So thank you also for the consideration and invitation to NEL Hydrogen to this webinar, and also thank you to the association. So I will try to explain what is doing our company, and I will try to comment during these slides. Next. So our company is a company of Norway. We have our headquarters in Oslo, and we are a leading hydrogen technology company, specialized in two business units: electrolyzers, water electrolyzers, and hydrogen fuel stations. For the water electrolyzers, we have two technologies. As you can see here in this slide, we are in the middle of the connection of the renewables and utilities with the use of green hydrogen in industrial applications. We are in this intermediate phase that is important to make this new hydrogen market grow in the next years. Next. We have two technologies, and in fact, in our group, we have two main factories. One factory in Norway for the alkaline electrolyzer technology, and also another important factory we have in the United States related to the PEM technology, proton exchange membrane technology of electrolyzers. In both technologies, we are growing in production capacity, but also in new developments and new improvements in the designs and installations. Next. Our company is special because in the same group we have the two main technologies of electrolyzers, and also we work in different range of production, from small electrolyzer systems for testing, industrial use, medium size that could go up to 20 megawatts, and also bigger, large scale size that up to 100 and even bigger than 100, hundreds of megawatts. The renewable market is moving in that direction. The renewable market is moving to larger scales, taking the advantage of the renewable feed. And in our case, we are also being prepared to attend larger and larger projects. But having said that, also we maintain our product portfolio in all the different sizes of projects. Next. I will explain in the next one how we look to the market and also what applications and opportunities we see in this new green hydrogen market. In the next one, please. So, in fact, our company is a company that was established 90 years ago in Norway. So we are joking, we are told to be an old startup company, because in fact our company is old, but we are like in a startup in a new phase because of the renewable energy, how mature is becoming and how can be decarbonize the industrial applications and different sectors. This is what is happening. We know the technology, but we need to increase the production and the scale, and also we have experiences in different sectors that is in fertilizer is one of them, in semiconductors, in chemical industry, in the steel industry. So the sectors are there. The difference today and in the future is how the renewable energy will be able to replace natural gas and to use hydrogen as energy carrier or also as a raw material for industrial processes. Next one. Because at the end, we are not a new company. Our company has delivered thousands of electrolyzers in different sizes. But as you can see in the top, in the left, the old photograph, our company 90 years or 80 years ago already developed large green ammonia electrolyzer projects. At that time was with Norsk Hydro, taking the advantage of hydropower in Norway. But that type of production was already produced, designed, and installed. The difference with today is that going to industrial scale, you need more automated production to go to a larger production. But the technology is there. We need to improve different sectors and different parameters, but the knowledge is there. We have experience in chemical sector, semiconductors, in mining. Recently also we are obtaining orders for electrolyzers for the steel sector, to decarbonize the steel sector. In Australia we have also activity. So as you can see, our company is not new. We have this experience that is the base for our new growth. In the next one, please. What is happening today is that the projects are going to a larger scale for different industrial applications, including green ammonia. We are preparing our company for these large projects in both technologies, in the alkaline technology and in the PEM. We have research and development projects, and also we have standardization. What is important when you go to large scale is to standardize your solutions in order to reduce the risk to the clients and for the installation on site. That is what we are developing, this industrialization. We are preparing our production facilities for this large scale, and that is where is currently our focus. We are growing as a company, and we are incorporating more and more engineers and employees. Next one. For instance, the market, the green hydrogen market, is moving so quick that with the support as well, of course, of the European Union and in the United States with the administration. But what is happening is that the needs and the demand of the market are there, but the offer and the demand is not yet balanced. We, companies like us, we don't have yet the capacity to attend all the projects that could come in the future. But our company, NEL, is having a leading position because we already have a fully automated production line of 500 megawatts per year. But because of the last movements in the market and also last contracts we have been awarded, that is the leverage, that is the support to invest in more production capacity. As you may understand, we cannot invest in bigger capacity if there is no support from clients or from real projects. We have to be cautious, but what we are doing is we are investing in production capacity at the same time that clients are committing to work with us. By 2024, we will have a second line of production installed, and we will have a real automated production capacity of 1 gigawatt by 2024. But depending how the market evolves, even we have our plans are more ambitious. Our company will still be growing to accompany our clients and our partners. The next one. And some examples, no? I will talk now about the Iberdrola and Puerto Llano project, but also how the market is moving. This is recently, some months ago, this is an interesting project because in this case is a pilot project, is to demonstrate renewable energy fluctuation to produce green ammonia in the synthesis reactor that one company, in this case Topsoe from Denmark, will install after our electrolyzer unit. So it will be a complete demonstration line of renewable green electrolyzers and green ammonia production. And there will be a lot of learnings from this project that later will go to industrial large scale. So this is happening now. And of course, in the next one, this is the Puerto Llano project of Iberdrola. Iberdrola is an important company. It's one of the leading renewable energy companies in the world. This is one of the biggest and most important in this sector. They were pioneer. This company, Iberdrola, is in the front line of the green energy market because they started many decades with the wind energy and wind renewable energy. They entered in photovoltaic solar projects, but now we have the same vision. This important company and client and partner, Iberdrola, and we have the same vision to decarbonize the society, to decarbonize the industry, and to implement and use and help the green transition in our society and in our industries. So we are accompanying this company, Iberdrola, in the project of Puerto Llano. It was an honor for us, for Enel, to be considered and selected by Iberdrola for this project. Iberdrola selected the PEM technology in this case. As I mentioned, we have different and several and both options of technologies, alkaline and PEM. And in this case, depending the project specifics, it was decided to consider the PEM technology. And this project is still in tuning. It's in tuning and in trials and in operation, in prudent. It's a complex project. And what we are doing now is, and I can explain you how the system works. So we have the PEM electrolyzer stacks that are designed with, to work in groups. As you can see, in this case, there are 16 electrolyzer stacks that are fed by the rectifiers, and also the rectifier receive the power from the transformers from the solar power plant of Iberdrola. But let me explain you in the next one, and this is just to finish, so you can see also more information of our company in our webpage. But now we can see a short video how our technology looks like.
Thank you, Emmanuel. And the video will be starting soon, I guess.
Yeah.
Nel, the leader in on-site hydrogen generation, is taking our M-series PEM electrolyzers to the next level for high-volume hydrogen customers. Our M-series electrolyzers are based on standard and proven cell stack and power supply modules and aggregated into a compact and cost-effective balance of plant. Ranging from the M2000 producing over 4 metric tons per day of hydrogen to the M5000 producing over 10 metric tons per day, the M-series plant design provides modularity without excessive redundancy. Oxygen phase separator, heat exchanger, water circulation pumps, electrolysis cell stacks, DI water polisher, hydrogen phase separator, hydrogen dryer, and it all comes with the proven attributes of Nel's PEM electrolyzer technology, including low maintenance, safety by design, and decades of reliability.
Yes.
All right, so thank you for that, and thank you, Emmanuel, for the very nice presentation. And you know what's the most interesting thing is that we move from these nice videos to actually a plant that is running with these nice videos. You know, so that's I think the biggest takeaway here is that there's actually a plant running on these units and they exist. So that's really great. And I wanted to go for our first question to Mark. So what were actually the kind of drivers for this project to be first of a kind? Is it there's probably a lot of risk involved to be the first of a kind. So what were the key drivers? Is it the off-takers, the government, or is it mainly like internal wishes?
Yeah, well, it's important to learn, to start, and to work away, let's say, the issues once you're doing it, because you can think big, but it's not so easy to think to work big. So it's the Puertollano site was an excellent site because of its solar capacity and its and the fact that we are already have the capability to absorb, let's say, the hydrogen that's being produced. We're not dependent on a hydrogen market that needs to develop for transport, so we could actually use the hydrogen at scale and start to work with producing the green ammonia. But there's still a lot that's going to be that needs to be done in this phase. We have to work on the certification, because what makes green ammonia different from gray? Nothing actually, only the certificate that you add to it. The rest is identical. It's the same product. The same accounts for the green hydrogen. This is all under development at this moment, and we're doing it and we're working on it, and it's super important to get it. But the other thing that needs to be developed is the market. And you cannot, if you change over an ammonia plant completely, the market is not ready to absorb the green product as it is right now. So we are carefully selecting our customers that are working on the green fertilization route, and see that as a very important aspect of their business. And that starts with relatively small volume. So it's better to start a little bit smaller. And then once, let's say, green ammonia becomes common practice, and it's going to be in larger volumes as in your forecast, yeah, then there will be more or less of a wash between green and gray, and then that market is going to be is going to develop, and we have to see how quick it develops. But this first quantities that we produce is really based on let's say developing also this specific green fertilization market that we think is valuable for our specialty strategy that we have within Fertiberia.
Very clear indeed, and probably looking at the nitrate production, that's probably also the lowest hanging fruit that you have in the fertilizer production. I want to ask Emmanuel, so there's this project with this intermittent solar power, and you have electrolyzers. How did you prepare in the past 5-10 years to be able to actually say, okay, we can offer you this technology that can operate intermittently with the solar power?
Yeah, so it's a good question, because this is emerging technology. It's a new in his kind, no? So what is important to consider is don't underestimate the complexity of these projects. Everybody is looking in the media, in the global news, projects going to 100 of megawatts of scale. That project will happen, but it's important to start with a pilot or a small scale projects in order to de-risk this type of new technologies. So that will happen. We have started with this project of 20 megawatt, this project of Iberdrola. Iberdrola was pioneer because there was no other project like that in Europe. And also, this is in PEM. With alkaline, also, when you talk about the renewable intermittent dynamic production, it's also something new in the electrolyzer market. The technology is there, but it's important, very important, to de-risk the project with pilot, demo project before going to the 100 of megawatt scale. It can be done, but it's also important to do the project in phases, and also to do an important upfront FEED engineering studies to try to de-risk as much as possible before facing a new complex project.
Yeah, very clear. So you're talking about scale up and you prepared your technology to be ready for this project. So what are kind of the takeaways for scaling up this project? Is it just building the same installation but then 5 to 10 times bigger, or do you have specific things that you would like to change to optimize the cost probably?
Yeah. So there are different elements. I will say that there are 3 different levels. One level is the automation and automated production line. In our case, we have a fully robot production line that is new, state of the art. With that type of installations, you reduce the cost of production that in the past was more labor or manual work. Today is fully automated, so you can reduce some part of the cost and also improve the quality and reduce problems in the production line. The second is the standardization. Standardization is an important work in this new type of projects, going to large scale. We need to standardize our technological designs and solutions, but also we need to standardize in modular concepts when you go to a bigger and bigger phase. And the third point, and not the last one and the less important, is the continue making research and development to improve the efficiency of your technologies. We have today's solutions, but if you foreseen the targets for 2030 or even before 2025, you need to develop new ideas, new works in order to keep on improving. Don't forget that the cost and the capex of the electrolyzer plants are important, but the most important driver for green electrolyzer plants is the cost of the electricity, of the renewable electricity. It can suppose more than in OPEX than the 70% of the total OPEX. So it's important also to improve your efficiency continuously, not only as of today, but in the future when you go to a bigger scale. That will be a very important driver for the clients, no?
Very clear, and indeed, it's from the electrolyzer perspective. Indeed, the more you build, the more you can automate, the more you can build bigger factories. You need to start somewhere, right? So that's one thing. So I also want to ask Mark. So if you look at this project in Puerto Llano, would you just build it 5 times bigger, or are there some key takeaways where you say, okay, we need to do this differently?
Yeah, we've learned a lot of this project, definitely, and it's the one thing that is I think is important for the next step is to go for 100% green ammonia plants, and we think that it's wise to go for 100% green ammonia plants in that case, because then you can work on the ammonia production. For which you only need, let's say, the last part of a normal ammonia plant based on natural gas, and that part is a relatively flexible part in production. So there you can, with some storage of hydrogen in between, you can follow the renewable pattern and keep the plant running during day and night, not going all the way up and all the way down all the time. But that's a very important development, and I think that's also where we think that there is the future. On the other hand, especially what Imanol says, it's very important to get the right green power in your project, to have the good combination of your green power assets with the availability of that power, in combination with the electrolyzer, in combination with the hydrogen storage, and then the ammonia plant sizing, which is very important. And normal scaling rules like you have with gray ammonia are a bit different if you talk with green. It's so that's something that is also a good lesson that we learned from, let's say, the different projects that we do, but also the simulations that we do for these projects. That is an important factor.
You're totally right, and like electrolyzers are modular, solar panels are modular, wind turbines are modular, so it's also numbering up and making that more efficient, rather than just the simple scaling rules that you have for a Haber-Bosch or for a steam methane reformer. One thing that I want to ask you is you have now an existing ammonia plant, and it's highly heat integrated with your natural gas production, hydrogen production from natural gas. And it's considered to be less flexible. But in your opinion, could you revamp an existing ammonia plant to be as flexible as you would build a new build renewable ammonia plant?
Yes, but you have to decouple the front end from the synthesis end and make it really separate. Yeah. Then it's
so that is technically possible and also economically a viable option to do.
Yeah. That depends on each situation is different there. So it depends on very specific situations. But I think at a certain moment, if you look at within Europe, I think most of the ammonia plants are of a certain age, and you have to reconsider if you want to keep on using that equipment for another 50 years. So it's if you want to be in the business for another 50 years, it could be wise to reconsider building a new green ammonia plant, which is basically only 1/3 of a normal gray ammonia plant that you need to rebuild. So it's not the world.
No, very good. That's also very clear, because in Europe, especially, the average age of an ammonia plant is quite high compared to the rest of the world.
Yeah.
Another question that I got from the audience, really regarding the water supply, because a renewable ammonia plant uses more water than a steam methane reformer based ammonia plant. Is there any issue regarding that, or is it in Spain quite well regulated?
Yeah, it's true, but it's not that dramatic as it sounds, because steam methane reforming also uses steam, which is also water, and a significant part of the hydrogen that you actually consume or comes out of a steam methane reformer is based on the water that you put in. So it's not if you change over, let's say, a gray ammonia process into a green, the total water consumption is not that much more. Actually, it's quite considerably smaller. Secondly, if you produce fertilizer afterwards, you get a lot of the water back again that you put in the beginning. So it's also there. the combination with green ammonia and making fertilizers is then a advantageous process in areas that are, let's say, less water rich. And which is in Spain, but we have in the projects that we choose, we have plenty of water available or rights available to do what we need to do. And as said, the amount of water that you need extra, especially combined with fertilizer production, is not that much.
Thank you for that. So now I would like to move over to the electrolyzer, and Imanol's the expert probably here. So is there, if you look at the foreseeable future, do you expect any specific electrolyzer technology to be dedicated to, for instance, grid-connected electrolysis or solar power electrolysis, or is this more what the client kind of, or the customer kind of wants? What is kind of the difference between ordering an alkaline electrolyzer and a PEM electrolyzer?
Yeah.
Can you take me there, Imanol?
Yeah. Yes, good question, Kevin. So, as I explained, in our company, Nel Hydrogen, we have both technologies, no? It's like with the sons and the daughters, no? You cannot say which is better, because in this technology, both technologies will coexist in the future. We believe that the selection of one technology or the other will be more for project specifics in the discussions with the clients and in detail in the analysis of what is the best design. But both will coexist, and we are preparing the roadmap of the improvement for both of them in the future. And there will be projects where alkaline can be selected because it's a less expensive solution, also very efficient. And on the other hand, the PEM technology has a better intermittency and also the quickest reaction to the renewable power feed. But also it has the advantage of a reduced footprint in places where the clients, in the industrial plants of the clients, if they have problems of space, this can be a good option. So, but on the other hand, the PEM electrolyzer technology is also more expensive. It has to be also evaluated well. And it's not only more expensive because we use special alloys, special metals, iridium, platinum. That makes also a supply risk, a supply chain risk in the market. With the technology of alkaline, you have less dependency of special alloys or special metals because you use carbon steel and nickel-based alloys. So if you put in the table many parameters, no, is cost, efficiency, supply chain risk, footprint, reaction time to then is when you have a matrix of parameters that help the discussion with the client to select the best choice for each specific project. Having said that, on the other hand, we are looking more and more that it could come in the future is a hybrid combination of both technologies.
Exactly, yeah.
Where the alkaline could have a high base load of production for clients that want to have a full robust production line. Alkaline could be used as a good support base load, and the PEM can be complementary just for the peaks of quick renewable energy that could be in the range, just for say a range of percentage, it could be 10%, 50%, that the clients can play with this excess and quick renewable energy to manage and use the peaks of energy intermittently. So this is a new option that will appear in the future. But in a summary, the technologies will coexist. These are the most industrialized and more advanced technologies as of today for industrial use. There will be projects only with alkaline. There will be other projects with PEM. And there could be in the future combined projects with both technologies.
Thank you for that, Imanol. It's very clear indeed that both have their pros and their cons, and we probably want to work with them both, and maybe even new technologies like steam alkaline or high temperatures like solid oxides, maybe alternative technologies like anion exchange membrane electrolyzer. So there might be new technologies, but for now, alkaline and PEM are the main options that are commercially available. So,
and also, Kevin, just not to forget the idea that the client need to develop and to have the green renewable energy. But there could be cases, and there are some type of projects where the client allow or obtain this green energy not with a closed renewable plant. They can close long-term PPAs of green energy, and that could be also in order to feed continuously during all the day with green energy, but through a grid connection. That is a project-specific case, no?
No, very, very clear, very clear. Now I want to move on to a question I got from the audience, and it's specifically from Mark. It asks whether the oxygen gas that comes from the electrolysis, which is often a byproduct with the hydrogen and not always used, does it serve a specific purpose for Tiberia?
It could, but it doesn't do it today. Where we see in fertilizer production that there is an advantage if you use the oxygen to produce nitric acid. And nitric acid, of course, you use by oxidizing ammonia again, and then it makes nitrates, and it has an advantage to use that oxygen in that process. But for that, you need a more constant flow of that oxygen than we have today in this test phase. And so it is foreseen to use it in the future. And it gives it gives an advantage in the nitric acid production.
Thank you for that. So that's more on the technical integration side of the entire fertilizer plant. So just wondering more on the regulatory side of things. So is there enough support in the regulatory framework in Europe? And you already mentioned that certification is not there yet for the renewable ammonia. Is there already some help from the EU, for instance, European Commission, to help you along the journey to decarbonize? Or do you need more?
It's never enough, but it's on the other hand, there are at this moment there's one thing, of course, is certification, what you said. So for that we are working already on a certification pilot, and of course the Pretoriano plant is one of the first to be tested to see how this certification would work and could work. If you look at the support mechanisms within Europe, I think that can improve, especially if you look at the rest of the world. But I know for sure that there is quite a strong agenda within the EU to support and to repower Europe, especially with a number of fundings. And it's sometimes a bit difficult because you're working on one fund and then they find suddenly another fund and another fund, and so it's a bit difficult to make your choices at this moment and to see what's exactly the right thing for which project. That's at this moment it's kind of moving targets.
Yeah, very clear, and also because the numbers are quite large and they are kind of abstract sometimes. What does it even mean to have so much hydrogen coming to Europe, because we're not used to this kind of quantities. Also asking Emmanuel, also what Mark briefly mentioned, in other locations there's a bit more action going on, and I think he partially refers to the US, where you have the Inflation Reduction Act coming into law. So Emmanuel, do you already see some movement or more concretization of the projects in the US following this law?
This is moving, but the projects will take time. No, there are a lot of projects in pipeline, in study, in development. But in Europe, it was interesting because in Europe there was a long discussion from many years ago with the Green Deal. That then, after the pandemic, and now with the war, Europe needs to diversify and to use renewable gases. So with the repower and the Fit for 55, now in Europe that it was discussing this, at least 1 month ago in August, the European Parliament voted in the direction to support the use in the industry of more green hydrogen. So the good thing in Europe is that it seems that now with the support of the European Parliament, this can go, or this will go quicker. This has to be still in the next months to be fully approved. But the good thing is that in Europe now we have targets. There is a target to decarbonize, and it is commented 50% of to replace with green hydrogen in the high intensive energy industrial companies. And also for the mobility, there start to be targets. But from our perspective of the electrolyzer producer, electrolyzer manufacturer, the good thing also is that the plans and the ambitions of Europe is very important. And I think it can be supposed an important mix in the future energy mix. But for manufacturers like us, a big difference is because to create this ecosystem of electrolyzer projects, it is needed capacity of production. But the European Union is thinking also to provide funds through innovation funds to increase the production capacity of electrolyzer in Europe in order to sustain the clean energy objectives in Europe. Because if not, you can have objectives, but if there is not electrolyzer in gigawatt capacity, there will not be projects. So
just trying to understand. In the past, you probably only sold electrolyzers to ammonia plants, so that was with the Norsk Hydro plants and also in some other locations around the world. So right now, if you look at the coming years and kind of the orders that you get, is it still mainly ammonia, or is it a very diversified field with refineries, steel production? How is this market more or less?
Our vision is that ammonia will be in the first level. The market will be there with the green ammonia applications, but also in that level is steel production that could take more time, and also in the refineries to replace the green hydrogen are the three main sectors where the electrification cannot reach and the green hydrogen can reach with the support of renewable energy. But Kevin, also to your question, in US, what is happening is that we were following, because our headquarters are in Europe, we were following very closely the European Parliament, how they are moving ahead the green hydrogen economy. But what we have looked in the last months also that in the US, they have speed the process with the Inflation Act, Reduction Act. This will be a game changer, because now in US, there will be supported many projects with the tax credits that they can obtain with the reduction of the glass greenhouses and with the use of green hydrogen. So we believe that the US will become an important market for green electrolyzers and green ammonia or other industrial applications of green electrolyzers. So US is running also now quick in order to make this happen.
Yeah, very, very clear indeed. And that's also what when I calculate the numbers, it starts to really make sense to go to very low carbon hydrogen production. But now going a little bit back to the markets and a bit to the future, and I would like to ask Mark regarding this, is that currently you produce a wide range of fertilizers, and now you partially replace your fossil-based hydrogen with renewable hydrogen. But at some point, you've done the easy part, like the nitrate production, and then you have to move on to the urea part, because you also partially produce urea. And you want to decarbonize by 2035. So can you take us along a little bit at the roadmap and the kind of the transition that you expect there?
Yeah, that's a difficult part for us to develop. But anyway, if you want to produce urea, and there will be urea use also in the future, if not for fertilization, for industrial applications or things like AdBlue, you will need to produce urea. For that, you need the CO2. And what was once a fatal byproduct almost of your ammonia process suddenly becomes a vital ingredient. And we see that the most reasonable use of CO2 will be the on-purpose production of bio CO2, more or less, which is the easiest way to get your CO2. And if you do it correctly, you will have also some additional hydrogen as a byproduct of that CO2 production, actually. And that is something we see as a viable route for the future too, for the sites that we have where we produce urea. So produce just enough CO2 that for which you need it, and have a little bit of additional hydrogen available to supplement the ammonia production, which is from a biological source and will therefore be a sustainable form of ammonia that you produce, and supply the rest with green hydrogen from electrolysis process in our Spanish plants.
Very clear, and also even with the biogas, you probably produce more CO2 than you would actually need for your urea if you do it with an SMR kind of technology. So you're even able to decrease the net carbon footprint, and maybe you're even able to offset any emissions downstream utilizing the fertilizer. So that could be an added benefit as well. If you look now, like 5-10 years from now, when are you happy? Like, when has this journey of decarbonization been a success in the 2020s for you?
I think if let's say we manage to get the projects that we have now planned, get them from, let's say, the drawing board and the feasibility phase where we are in now, and towards actual construction and potentially startup. Because if you look at what we have now on the drawing table, that's enough to decarbonize our food production, which is quite interesting. And we should have our first projects in expanding, making more, and making a really good future for green ammonia and green fertilization in Europe as Fertiberia. Maybe even expand to new markets. Yeah, possibly, but so far our focus area is Europe, European production, once we have, let's say, enough experience in how it's being done, we could look into further markets, definitely further on. Yeah, clear. Now, if we go a bit back, Emmanuel, to the Mission Possible partnership report. To reach the 1.5 degrees scenario, we need to invest in maybe 5 to 10, 1 million ton per annum ammonia plants up till 2030, and beyond that it's even more. So that's multiple gigawatts of electrolyzers, tens of gigawatts every year. And so just wondering, for you, 5 to 10 years from now, when are you happy with regards to the electrolyzer capacity and the sales regarding to that?
I can share the vision of our company because we have a long-term plan. No, at the end, we believe that the world is changing. The world is changing as we knew in the past. Now we have more complexities. We have also risks with the increase of temperatures, the decarbonization that the society is moving. Don't forget that the societies who is moving these trends are not the companies. Are the society who will demand more electrical devices, more electrical cars. That is in the mind of people, no, to make something change, because if not, we can fail as a society for the next generation. So, looking to the future with this decarbonization, at the end, we believe that the green transition will not replace totally the fossil fuels, but will be an important mix in this green transition. And there will not be green transition with no green hydrogen. And also there will not be green hydrogen without green electrolyzers. So we are in that way, and our vision is that we have an ambitious plan to produce and to have 10 gigawatts of electrolyzers automated facilities. And this will happen this decade. But it's funny, in our young old company, that 5 years ago, we had a capacity of production of electrolyzer per year of 100 megawatts. Last year, we have 500 megawatts. In 2 years, we'll have 1 gigawatt. And we will still growing until the vision that we have in our business plan, 10 gigawatts of electrolyzer production, combining both technologies, alkaline and PEM. This is our wish, and also the important to contribute with our clients like Iberdrola, Fertiberia, other industrial clients in the green ammonia sector to try to contribute to make this dream possible. No?
Thank you so much, Emmanuel, and also Mark for the vision towards the future in the coming decade. And it's very enlightening to see that we're actually on the path to realize this, because it's one thing to show nice videos and to like have these nice drawings, but it's the best thing to see them actually in operation. And this is one of the first projects that actually does that. So thank you so much for that. And thank you for being in this conversation with me. Next month, we actually move on to Northwest Africa, where we will talk with CWP and System IQ about renewable ammonia projects on the gigawatt scale, electrolysis-based hydrogen production in Mauritania. And then Nouri Chahid and Lloyd Pinner will be joined by Andrea Guatirojo from the Ammonia Energy Association. And the link to sign up to this webinar is already in the chat. So please feel free to subscribe and join this webinar as well. But I really like to thank both of you, Mark and Emmanuel, for bearing with me for the entire hour. And I think there are quite some nice takeaways from this webinar. And thank you so much.
Thank you.
Thank you too for the invitation.
Thank you.